All right, welcome back. Last video about factoring techniques. Let's take a look at what happens, the hardest case, when A is not 1. And so off we go. So first things first, we always look for greatest common factor. So I have 3 problems we're going to look at right here. Of course, the only thing that divides nicely into 3 is, well, 3 and 1. But 3 doesn't go into either one of those. And in fact, when we say common factor, it has to literally be a common factor. Same thing here. 5 is a prime number. The only thing that divides into 5 is 5. Now you'll notice right here the number 28, 21, 28 and 21, those are all divisible by 7. So we will actually deal with that. But regardless, in all of these cases, we're going to tangle with the hardest kind of factoring, where A itself is not 1. So the trick that we have, or the process that we've taught, and again, there's a lot of different ways. So if you follow other videos, look at other descriptions, there's a lot of ways to factor. This is just a way that we felt like was fairly straightforward for people. But the product goes here, that's 24, and the sum goes here, that's 14. Now I got to go through numbers that multiply to 24, 1 and 24, 4 and 6, whatever. But 2 and 12 have a product of 24, but a sum of 14. And notice that there's no negative, so everybody is positive. Now, unlike the previous videos, I'm going to have to use the area model because it's actually important as being part of our story when our A value is not 1. So remember what happens in the area model. Your front number goes here. That's your 3x squared. Remember, everything is going to be actually factoring this. This was simply a tool to help us get there. The very ending value, this 8 right here, is going to sit out in this hole. And then what we have left to deal with is the number 14. Now, the 14 needs to sit in this gap right here. But I need that 14 to be split up into 2 values, and we found from here that we're going to split it up as a 2x and a 12x. Now, as a side note, it is really important that part of the reason this works is if you look at this diagonal this way, 3x squared times 8 is 24x squared, and 2x times 12x is also 24x squared. But what I like to do is I like to look for a common factor. So when I look at these two right here, I look and I see that they both have a 3 and they both have an x. So I could write 3x here. Or I could look right here and see that they both have a 4 in common. And it really doesn't matter anywhere you look, as long as you look for what they have in common. Notice there's a 2 right here. But I'm going to look at these and notice the 3 and the x. Well, 3x times x is 3x squared. Notice that they had an x in common. 3x times 4 is 12x. Notice these have that 4 in common. So we could have actually started with the 4 and figured out that that was 3x. We could start anywhere I want to, and it works. But x times 2 is 2x. And you'll notice that we never really bothered to look at this 8, but 2 times 4 is 8. So that kind of checks my answer. And so I know that this now factors to 3x plus 2 times x plus 4. And again, it would not at all matter if we reverse the order and put the x plus 4 first. It's the same thing. And as far as checking our answer, it turns out it's fairly easy because we already have that right here, because I can already see that I'm multiplying 3x plus 2 by x plus 4. So I have those building blocks, and I can see this is 3x squared plus 14 and 8. So we have it already checked in the process that we actually wrote that up. Okay, problem number 2. We're only going to do 3 on this one. We put a times c on top, that's 30. We put the negative 17 on the bottom. Not a super hard problem. 30 is either 1 times 30, 2 times 15, 3 times 10, or say 5 times 6. Again, that's that funnel method. As we write those numbers, as this one gets larger, this one gets smaller, and they kind of come together. And I think we could see that we could get the number 17 if we made these both negative. And so again, very important that we actually take the time to make our box. So we got our 5x squared here and our 6 here. Remember, the front number goes in the top corner. The back number goes in the bottom corner, and then the 17 right here is determined by those values. And so I'm going to put a negative 2x here and a negative 15x here. Now, like I said, I just look for something that they have in common, and my eyes absolutely immediately looked at these and saw a 5 and an x. So 5x times x is 5x squared, 5x times negative 3, because 5 times 3 is 15, but I needed that to be negative, and x times negative 2. And we can also see right here that that worked, and so we're good to go. We got x minus 3 and 5x minus 2. Again, check step has already been established in the above. And here's my last one. This is the hardest one. This would be the one I'd put a star next to because there's one extra little piece. Notice on this problem, those numbers would be absolutely horrible. In fact, I'm going to grab a calculator because I don't even know what it is. 28 times 21. If I were going to do the diamond problem, I put a 588 on top. I don't want to do that. That's awful. So always look for those common factors. So if I divided 28 by 7, I'd get 4. Again, 4, and 21 divided by 7 is 3. So keep in mind, I'm going to store this 7 sitting in front, but I'm going to go ahead and figure out what those other pieces are. And I'm going to do the diamond based on this smaller set of numbers. So I'm not going to think of A times C as being 588. I'm going to think about it as being 4 times negative 3, which is negative 12. And now 1 and 12 is either 1 and 12 or 2 and 6 or 3 and 4, but I think you could pretty quickly figure out that 2 and 6 could work if I made the 2 negative and the 6 positive. Please don't write x minus 2 and x plus 6 because we're guaranteed that that is going to be incorrect. Okay, let me hit pause for this for just 1 second, everybody. Okay, sorry about that. I got a phone call. So anyway, so let's see what's going on. In our last question, we pulled out that 7. We came over here. Again, please understand I'm going to ignore this 7 that's sitting in front because I'm storing it here for a later time. Remember, we put the front number here, the last number goes here, and the 4x is going to be split between a negative 2x and a 6x. Please, please, please don't forget the x's. Some teachers teach their students to put the x's and the x squareds here. I choose not to do that. And we're just going to go really quickly and look for that greatest common factor, 2x and a 3, 2x and a negative 1. And there we go. That is your common factor pulled out, A not 1. The hardest part of it is quadratics that we do. Hey, I'll see you back in class. Hopefully that was helpful. See ya.